Holy smokes! Stop! Write this down. Pause it. Pause it, I said. Pause it! You answer. You listen? Okay. An airplane is flying towards a radar station at a constant height of 6 kilometers above the ground. If the airplane and the radar station... No. If the distance, s, between the airplane and the radar station is decreasing at the rate of 400 kilometers per hour, when s is... it could be a comma there. When s is 10 kilometers per hour, maybe not. 4 kilometers per hour, 400 kilometers per hour, when s is 10 kilometers. What is the horizontal speed of the plane? Holy smokes! I don't know what's going on. What do you think we gotta do? I think we gotta draw a picture. So maybe you should try draw a picture right now. There's a radar station. This is a little simple thing here. That's the first thing we gotta do. So I'm gonna draw a picture. Maybe you pause it and try to draw a picture on your own of this situation, not just like a little doodle. An airplane is flying towards a radar station. Just in my brain, the airplane is flying. Look at this. This is an airplane. Woo! And that's pretty good. Cool. That's the airplane, and it's flying towards a radar station. It's flying that way, and I'm gonna say like this is a radar station, like this. Beep 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 beep. That's the radar station. Woo. Okay. So it's flying towards the radar station, and it's 6 kilometers above the ground. It's a constant height, 6 kilometers above the ground. I'm just reading this stuff. You can't make this stuff up. Somebody made it up. But I'm just reading it and drawing the picture. So this distance, let's do that in a different color. That distance is constant. It's a constant. Maybe I'm gonna do it on the other side. It's a constant 6 kilometers. So there we go. That distance from there to there is 6 kilometers, and it stays that way. Very nice, very nice. Let's keep reading. If the distance s between the airplane and the radar station, I'm going to consider that to be a distance that's at an angle, a diagonal distance. There we go. I'm going to call that, what is that? If the distance s between the airplane and the radar station is decreasing. Okay. So this distance is called s. S there. And that's decreasing. Ooh, it's a negative. It's decreasing at 400 kilometers per hour. Yeah, when s is 10 kilometers. What is the speed of the plane? Okay, so I think we got this picture all drawn. This is a pretty picture. I think we got the picture all done. So now what happens? Well, I'm starting to look at this. I'm starting to think like, look, I see a relationship between these things. I see that's a right triangle. Do you see it? Do you see it? And I want to label, this distance here never changes. So I don't need to make it a variable. But this definitely changes, right? That distance changes. The idea is, how fast does that change? Because if we find how fast this changes, then we'll find how fast the plane is going, right? So that's something to notice. What do you want to call that distance there? I'm going to call it plane P. I'm going to call it plane because it's the plane. The plane decides that distance. Okay. Now that we got a picture with all the variables on that, with the distances, we got to look at the rates. What does it want, or what does it give us? It says the rate at which, if the distance s between the airplane and the radar station decreases at a rate of 400 kilometers per hour. So this is decreasing. We should get a decreasing distance for that, or I mean a decreasing rate for that. But what is it? The rate at which s is changing with respect to time. So that rate, we'll write that down, ds dt. the rate that s changes with respect to time, and then what is it asking for? It's the rate of the plane, or the speed of the plane. That's the speed of this distance changing. So that would be dp dt. And that will be the rate that p changes with respect to time. Well, we are given, what are we given? Looks like we are given ds dt, right? ds dt equals, like, you could, I mean, I guess you don't really have to make it a negative 400. You just have to know that this is also decreasing. So if you make this negative, that will end up being negative as well, because it should. I mean, it should be. Because I said in the last video, it would be negative. So let's say 400 kilometers per hour. So km per h per hour. I'm just going to say an hour. And I know it's decreasing, and I also know that the distance p should be decreasing as well. So the rate that I get for dp dt, that should be negative at the very end. So that's what it wants. That's what we want. What is the horizontal speed? The speed of the plane is the same thing as the rate at which this distance is changing. Because if this is getting smaller at a certain kilometers per hour, that means the plane is going that speed. So they're asking for dp dt, and we don't know what that is, but what do we when what did it say? When s equals 10 kilometers. When s equals 10 kilometers. Now, the only thing we need now is our primary equation. Well, would you look at that? I got a right triangle. How could I possibly relate S and P? Well, perhaps with Pythagorean Theorem. So I have here, because it's a right triangle, so I have what? P squared, this would be my primary equation, P squared plus, looks like 6 squared. Remember, you have to do the legs squared added together. So p squared plus 6 kilometers squared equals s squared. And there we go. How am I supposed to get a dp dt and a ds dt? Well, I take the derivative of that, don't you know? So that's what I'm going to do. Take the derivative. Remember, we're doing this with respect to time, because we're talking about speed here, and time is in hours. So with respect to time, if we take the derivative of that, we're going to have to use implicit differentiation. Well, that's just a constant. That's just 36. If we take the derivative of that, it goes away. And then here, that's well, again, implicit differentiation. So let's do it. Let's take the derivative of that junk. So d dt of all that stuff. So I'll start taking the derivative, and what do I get? I get, well, implicit differentiation says I take this 2p and then dp dt plus 0, that goes away, right? That goes to 0, and then equals 2s ds dt. Okay, great, fantastic. I need to solve for dp dt, so I guess I can divide both sides by 2p, or not 2p. Well, if you gotta go, you gotta go. So that cancels out, and what are we left with? We're left with dp dt equals, some people are gonna get confused at this, s over p, right? ds dt, that's the same thing. Like, it's okay to do that. It's just like s, dividing by 2 over p is the same thing as multiplying by 1 over 2p. So that's what happened there. Okay, great. I know what s is. S is 10, right? Great, fantastic. That's 10 kilometers. ds dt. Do I know what oh, look at that. ds dt, negative 400. That's nice. ds dt. But what about p? What about p? Then you get stumped. You're like, I don't know what to do with that. What? I'm freaking out. Don't panic. Grab your towel. Just look at this. Look. Check it out. I don't know what it is, but I got a way to figure it out. You go back to your primary equation. I already know that this is 10, right? So 10 squared is all that is. This is 36, and this is p squared. Can I not solve for p? Of course I can. This would be p squared equals, what, this is 100 minus 36? Well, that's just 64. So that means p is going to be, we're just going to use the positive version. P is 8, right? If you square root both sides, p is 8, not plus or minus 8, because we're talking about a distance. So there we go, it's 8. That's nice. So the t equals 10 kilometers over, what is that? 8. It's in kilometers also, right? Because it's a distance. 8 kilometers. And times negative 400. Sweet. Kilometers per whatever. Per hour. So we get another rate. So dp dt, and we knew it was going to be negative because the p distance is decreasing. What is this? 8 divided by 10, that's 5 over 2? Maybe? No. 5 over 4? And you multiply that by negative 400, that's negative 500 kilometers per hour. So that's how fast the plane is going. That's how fast the distance... I guess the speed of the plane, we would say, is... I mean, here we're considering this the rate of the distance changing. That's why it's negative. So the speed of the plane would be 500 kilometers per hour. This video is too long. So that's what I would say for that. Alright, man. I think hopefully I split this up into 2. Goodbye.